let's start. So the first rule we will talk about is called the product of power. Okay, and we'll start with a simple example. So you can write in the example one section. If I have P, okay. So if we start with a simple example, P to the power of 2 times P to the power of 3. What is this? Do you know how to calculate this? P to the power of 5, right? Because the first one is P times P, and then times P times P times P. So total of 5 P's, right? So we just are adding exponents to get the result, right? Nothing new. So can we generalize this rule? So what will be a to the power of m times a to the power of n? A to the power of m plus n. Nothing fancy. Right? So the rule stays exactly the same when our powers or our exponents are not integers but rational exponents. So the second example that we will put in is p to the power of 1 over 8 times p to the power of 4 over 8. So what do you think the answer is? P to the power of 5 over 8. That's it. Hello. Okay, any questions about this? Okay, so let's practice. Let's move now to the practice paper. So I'm just adding the exponents just as before, right? 1 over 8 plus 4 over 8. Ready? Okay, so now take the practice paper and let's do some practice. There are 2 examples that we will cover. So 5q r to the power of 3 times 2 q 1 to the 1 over 4 r to the power of 1 over 3, right? So we are taking care of the numbers first and then one variable at a time. So we have numbers 5 and 2. We just multiply them. So 5 times 2 is what? 10, right? And then we have q twice here. First with the exponent 1 and then with the exponent 1 over 4. So what do? We just say q to the power of what? Right, so it's 1 plus 1 over 4, right? And we'll simplify it a bit later. For now, just let's write out all the steps. And then we have r here, right? Twice. So r to the power of what? 3 plus 1 over 3. Correct? And now we can simplify. So 10 just stays times q. And what is 1 plus 1 over 4? No. 5/4, right? 5/4, correct? Because 1 plus 1 over 4, either can use calculator or we know that it's 4 over 4 plus 1 over 4, which is 5 over 4, right? Going back a couple of years. Okay, and then we take care of r. So we simplify r to the power of 3 plus 1 over 3 is what? Huh? 10/3. And that is our final answer. Questions about this? So just step by step, taking care of all these exponents. And remember, we only combine the exponents for the same variable, right? You can combine r and r, you can combine q and q, but not across. Questions? Good. Let's move to another example. Okay, so 7x to the power of 1 over 3 times negative 3x to the power of 1 over 5. Again, everything is just multiplied, right? So I have 2 numbers here that I could multiply. 7 times negative 3 is what? Negative 21. And then I have my x's, x and x here. So I just put x and I combine the exponent. I add the exponents. So 1 over 3 plus 1 over 5. Right? And I can rewrite this as negative 21 times x. And what is my new exponent? So 1 over 3 plus 1 over 5, either use calculator or we know that we need the same denominator, right? So it's 5 over 15 plus 3 over 15, which is 8 over 15, right? So x to the power of 8 over 15. Questions? Easy? No? But no questions, right? Just need more practice. Can you move on? Okay. So back to the foldable. Now we have power of a power. So the second section here. Starting with this simple example again. If I ask you what is p times, e to the power of a power. Oh, it's down here. It's in the corner. Make sure that you check the section header, right? Power of a power. So we have p to the power of 2, and then the whole thing to the power of 3. We know what this is. How do you calculate this? P to what power? To the power of 6, says Dylan, right? It's kind of simple, right? And intuitive. Okay, so can we generalize now? What is a to the power of m to the power of n? It's a to what power? mn. I just need to multiply the powers, right? Because it will be n groups of m, right? And again, even if you have the crazy exponent, like rational exponents, the rule stays exactly the same. So let's write a little bit more complicated example. D to the power of 1 over 4, and then the whole thing to the power of 2 over 3. Isaiah, are we good? Okay, so how can I simplify it? It's d to what power? What is my new exponent? Lily, what is my new exponent? How I calculate it? 1 over 4 times 2 over 3. And how do we multiply the exponent or the fractions like this? No, how do we multiply the fractions? We multiply numerators and we multiply denominators. No need for common denominator anymore, right? So 1 times 2 is 2 over 4 times 3 is 12. That's it. When we multiply fractions, we don't need common denominator. We just multiply numerator and denominator. Yes, we can definitely simplify this. This is d to the power of what? 1 over 6, right? Always try to simplify. Questions? Again, if you see something crazy, you don't know what to do with it, think about simpler example. You do know the rule. You've done this before. Just the numbers were a little bit simpler. Okay, so let's go to the practice and do a few practice ones. So this was power of a power, right? Okay, so second section. 16 to the power of 5 to the power of 1 over 4. So I can rewrite this as what? 16 times what? I mean to the power of what? 5, right? So because it's 5 over 1 times 1 over 4, if you need that written out, but it's, yes, 5 over 4. If you can actually calculate this, either using our calculator or, since we know how to simplify these terms, right? It's what? It's the 4th root of 16 to the power of 5. And what is 4th root of 16? No. Square root of 16 is 4. What is 4th root of 16? 2, right? So it's 2 to the power of 5. And what is 2 to the power of 5? 32. practice those skills. Simplify as much as possible every time. Questions? Yes. Next class, mini quiz on this. And always just try, the first thing to try is use calculator. If the number is great, nice. No need for factor ladder, no need to remember anything, right? You know how to calculate this on calculator, right? 16 to the power of 5 over 4. Always try. Hopefully the number will come out. Nice. Okay, so the next one. K to the power of 1 over 6 to the power of 2 over 5. So, Leah, how do I calculate the new exponent? What do I do? What do I do with the exponents now? Multiply. So 1 over 6 times 2 over 5. Can you tell me what it is? Without simplification. I need to multiply what? I don't know what cross multiply is. I don't want to say yes or no. I don't know what you mean. Multiply just numerator and denominators, yes. Yeah, I was thinking maybe you meant like cross like this. Okay, so 2 over 30, right? And I can simplify this a little bit. 2 over 30 is what? 150. That's it. Good? Okay, next section. Huh? So the other one was 32, I think. Okay, power of a product. Let's see where this is. Power of a product. So, okay, middle top section. So, let's start with a simple example. So, P times Q to the power of 2. What is this? How can we rewrite it? Yes. So, it's P squared times Q squared, right? And why is that? Okay, so what do we do? I need to distribute this power 1 over 2 into the parentheses, right? So every single one of these gets that exponent. Every single one of these factors. So what do we have? We have 4 to the power 1 over 2 times, then I have P squared to the power 1 over 2. And then have times Q to the power of 2 over 3 to the power of 1 over 2. See, I'm breaking this into factors. First factor, second factor, third factor. Each factor gets that exponent, right? That's our rule. So now we need to simplify this using the previous rule. So what is the 4 to the power of 1 over 2? 2. Everybody gets this? Okay, so what is P squared to the power of 1 over 2? It's just P, right? Because it's P 2 times 1 over 2, which is just 1, right? And then Q to the power of what? 2, 6. 2/3 times 1 over 2. So I can simplify this a little bit more, right? So 2 times 1 over 2 is just P times, and then Q, 2 over 6 is just what? 1 over 3. So that's my final answer after all the simplifications are done. What do you mean separate? I mean, you can write it without the dots, right? I just wanted to make sure everybody understands this is multiplication, that it's like this. You don't need to put like dots for multiplication. Questions? Okay, quotient of powers. Hopefully I'm pronouncing this right. Quotient, right? Quotient. Quotient of powers. Quotient of powers. Okay, so make sure you're writing in the right section. Okay, a to the power of m over a to the power of n. Can we come up with the formula right away without doing this simple example? Anyone? Hmm? Say it louder, Dylan, what you were saying? No, okay, let's try with a simple example first then. What is x to the power of 4 divided by x to the power of 2?
X2.
X to the power of 2, right? Because it's just x times x times x times x over x times x. So 2 of these x's cancel out, right? And I only have x to the power of 2 at the end. So now can we generalize? What is it? A to the power of what? M minus n. You don't need to remember, just like if you forget, just do simple examples. That's why we start with simple examples, so that you understand where the formulas come from, right? Always just do simple, and then you know the rule. Yes?
So you minus it or divide it?
Minus. Okay, so that was maybe a bad example. Let's do this one. 5. Oh. Right, so if this is 5, then I'll have extra. What did I do?
First that goes right.
Here. So if I have 5 x's on top, right? And then 2 x's on the bottom, so what would be my x to the power of what?
3.
3, right? So now it's clear. It's 5 minus 2, right? Because only 2 x's cancel out.
Yeah.
Okay, so when the exponents are crazy, rational, we have fractions for the exponents. Let's do one of those examples. So 32 to the power of 4 over 5 divided by 32 to the power of 1 over 5 equals what? 32, and what is the new exponent? It's 3 over 5. Right? So we subtract the exponents. 4 over 5 minus 1 over 5 gives us 3 over 5. So the rule stays exactly the same. Good? Okay, so let's try examples. Back to the practice. We are skipping one section. We'll come back to it a little bit later. So make sure that you're writing in the right section. Oh my goodness, this is wrong. Oh, here. Sorry, here. 20x to the power of 8 times y to the power of 1 over 2 is z over 25 x to the power of 3 y to the power of 5. Okay, so again, we take care of the numbers first and then variables one at a time. So x's and then y's and then z's, right, separately. So 20 over 25, can we simplify that? No. Is it 20 over 25? 4/5. So 4 over 5, right? I can divide both numerator and denominator by 5. Okay, so now x to the power of 8 divided by x to the power of 3.
That's 5.
X to the power of 5.
Is that going to the numerator only? Is that going to the numerator only?
Numerator, yes. Or we could just even write it like this, right? So it's even clearer, as we did before. So 4 5s and then times x to the power of 8 minus 3, which is 5. Let's write it like this. Even better. And then times y to what is the new exponent for y? Well, you see, I have y to the power of 1 over 2 over y to the power of 5, right? Y to the power of what? 1 over 2 minus 5, right? We need to do minus. Remember, we were subtracting m minus n, the top exponent minus the bottom exponent. right?
Negative.
So it will be negative. So it's y to the power of what? Negative 9 halves. And for now, we'll just leave it as this. We will learn how to deal with negative exponents just a little bit later. And then I have z only numerator, right? So what does it mean? Do I have z, and what is the exponent, the final exponent for z?
That might be 1.
Just 1, right? Because here I have z to the power of 1, and here I have nothing. So it's just z to the power of 1. Questions?
Is that the final?
Yes, for now this is the final answer.
That thing right there. All those dots in between.
This is just multiplication. You don't have to have them. You can just like leave them out. But it just tells you that it's multiplication, right?
Yeah.
Because you know how x times y, we just write
Already know
xy,
it.
right? Yeah. Just multiplication. Good. Questions? Okay, next example. Oh, you know what? We should have done the... You know what? Let's go to this one, negative exponent first, and then we'll go back to that example. See, I switched them without thinking of the examples. Okay, so negative exponent. Okay. If I have p to the power of negative 2.
Are we skipping the second one?
Yeah, I skipped the example. We'll come back to it. So let's go back to the polygon. Negative exponent. If I have p to the power of minus 2, right? Well, it's kind of, if you think about it, like having p 0 minus 2, right? You don't have to write it. I'll just explain it. Right? So negative 2 is like 0 minus 2, right? And if you think about the previous example where we divided quotient powers, right? Quotient powers, right? So you can think about these as if we did this. P to the power of 0 divided by p to the power of 2, right? Right? Make sense so far? And p to the power of 0 is what? What is... No. Anything to the power of 0 is 1. So the numerator becomes just 1. And the denominator stays as p to the power of 2. So this to show you why this rule works. So the general rule is whenever you have the negative exponent, you just put it like this. You put whatever is under exponent in the denominator, and the new exponent is positive. So this is just to illustrate where the rule comes from. It's not just like
So
made
it's
up
always
rule.
going to be a 1 over
Yes.
the positive number
Yes.
that used to be
Exactly.
there. Okay.
Yeah. Yes, this is 0. Not all this is 0. Right? But this is why this rule works. I was trying to show you. It's not like comes from the sky. Right? Okay, but this is the rule, and you'll get used to it. So. Okay, so let's do a little bit more complicated example, and this is important example, so pay attention. 12 times x to the power of negative 2 over 5. Okay? So now, make sure that you pay attention to what is under that power. This negative power applies only to x, doesn't apply to 12. There are no parentheses here, right? So only x will go into denominator. So what I have is 12 times, and then here I would have that 1 over x is the new positive exponent 2 over 5. So make sure don't put that 12 in the denominator.
Oh,
it's not
right.
there because the power, the exponent is only for x.
Oh, so it's two separate.
Right, right. If I had another example like this, 12x to the power of negative 2 over 5. In this case, 12 would also go into the denominator, right? In this case, I would have this 12x to the power of 2 over 5. These are two different examples. Yeah. Good. Just pay attention. Don't make that careless mistake, flipping over everything. Questions? Okay, so can you go back to that example that is skipped? Because see, there are like all these negatives. So now we know how to do them. Huh? Well, yeah, we can simplify this one also. True. We can even simplify this one, right? Because now we know how to take care of that negative exponent. So we can, I don't know if you have space there. I can delete this and rewrite it, right? So the negative, this y with the negative exponent will now go into denominator. So I could have written it like this: 4 over 5, and then in numerator I have x to the power of 5z, and in the denominator I will have y to the power of 9 over 2. See what I did here? Because of the negative power, nobody's writing. Because of the negative power, I know that I need to put y into denominator and change the negative exponent to the positive exponent. Confusing? Very? Uh-oh. Where did I lose you? It's just a lot, right? It is a lot. But the rules are simple because you've done all of them with this simple exponent. It's just the complication comes from seeing the rational exponents. You just need to get used to them. That's it. It's just like, it's just a number. Exponent is just a number. Integer or fraction, but it's just a number. Right?
Right.
Okay, so let's do this then. So my suggestion here is whenever you see the negative exponent and you're trying to simplify, first just clean up. Get rid of the negatives in the powers, right? So what we will do is we'll have 3, and then you see x to the power of negative 3. I'll just immediately put it into denominator instead of numerator with the power of positive 3. So you'll just switch it from numerator to denominator and change the sign.
Okay, and that one doesn't need to go up there because it basically speaks for itself.
Which one? No. So I'm taking one by one, right? So 3 x to the power of negative 3 goes into the denominator with x to the power of 3. Yes.
Wait, so if you bring it down and you turn the bottom?
Yes, right? That's what we did. Right? Change the sign. So now x to the power of negative 3, I can put it in denominator with x to the power of 3. Y just stays because it's, it's there. And z stays because the exponent is positive. It's positive 1. Now, denominator 9 stays. X to the power of negative 5. I want to get rid of this negative, so I'll put it back. X to the power of 5. Up. To switch.
So if you switch above or below, it's positive.
Yes, positive, negative switches, right?
That makes sense.
And now I have y to the power of negative 3 over 5. So I'll put it in numerator with the positive power of 3 over 5. Right? So whenever I see the negative power, negative exponent, I'll take care of it by switching numerator to denominator and back and forth. Yes.
So you just keep it 3 and 9 and change them over.
Oh, and now we'll simplify further, right? It's just before I do anything, I want to get rid of these negatives. Good. Okay, so now we can apply all the other rules, right? So 3 over 9 is what? 1/3. X to the power of 5 divided by x to the power of 3 is what? X squared. Y times y to the power of 3 over 5 is what? See, I have y times y to the power of 3 over 5 is what? Huh? So this exponent is just 1, right? So 1 plus 3 over 5. Right? So I multiply them, I add the exponents. And then I have z by itself. So a lot of little steps. Do you teach it like this? Do you switch? That's how I teach it. I don't want to do -3 minus 5 because then.
And guys, if you can't add these fractions in your head, like doing the common denominator and all that stuff, just put it in your calculator.
Yeah. So I'll just simplify. 1 over 3 times x over 2. X to the power of 2 times y. And then 1 plus 3 over 5 is 8 over 5. And then z by itself. That's my final answer. Questions? I know. Do your homework because you need to practice. Just make sure you do your homework. Otherwise, you'll make lots of mistakes on the quiz. It's just practice. Okay, so now let's move to this. This one should be easy, right? So 25 to the power of negative 1 over 2. What do we do, Hannah? Negative exponent. So what do we do?
You can't.
Yes, I need to bring this to the denominator, right?
Yeah.
So because it's 25 to the power of 1 over 2 and then 1 right there. Okay. And what is 25 to the power of 1 over 2, Yule? 25 to the power of 1 over 2. What is it? Okay, very good. Because this is just square root of 25 side. Right? So something this scary and unknown to something very simple. Good?
Hold on.
Good? Okay, next one. 1 over 3x to the power of negative 1 over 3. Right? So because I have this negative exponent, what do I do with this x? Where does it go? Up, right? If I want to get rid of the negative exponent, I need to switch from denominator to numerator. So x to the power of 1 over 3. That's it. This is it for this one. Because I'm switching negative exponent to positive exponent, I need to flip. But it's only x, because the exponent applies only to x and does not apply to t.
So it doesn't work.
Well, it's kind of like 1 times, so we don't do that. So you write it down, so it's 1 times, and we usually don't have coefficient, don't write coefficient 1, so it's right. So the last, and I think you have time to practice. Powers of quotient. Okay, so this simple one, simple example, x over y to the power of 2.
What's the difference between quotient of powers and
So quotient of powers is you have something like this, right? Oh, not even that one, right? Like this. And here we have the power of the quotient.
oh, so it's all in one.
Yeah, so this is quotient
Like
of 2
separated.
different powers. Okay, so x over y to the power of 2, what does it mean? It's x over y times itself twice, right? So when I multiply these two fractions, what do I have in the numerator?
X squared,
X squared, and what do I have in denominator?
y squared.
Y squared. This is simple, right? So we can now generalize the rule. So what is a over b to the power of m? It's what? A to the power of, not square, but to the power of m, right?
Oh yeah.
A to the power of m over b to the power of m. Right, I'm just generalizing the same thing. Instead of power of 2, I have general power of m. Okay, so now a little bit more complicated example. X over 27 to the power of 1 over 2. Oh, I'm sorry, to the power of 1 over 3. That's what I have here. By, to the power power of 1 over 3. Okay, so I have the power of the quotient, so I'll put in numerator I will have x to the power of 1 over 3, and in denominator I have 27 over to the power of 1 over 3, right? So I'm distributing that power into the fraction. Everybody gets the same power. Equals, so x to the power of 1 over 3 stays as is. But who knows what is 27 to the power of 1 over 3? What is it? 3. How do we know? Yes, so 27 to the power of 1 over 3, either use calculator, nothing wrong with that, or we also know that this is the third root of 27, right? Some of us remember this? It's just 3, because 3 to the power of 3 is 3. So I put 3 into denominator. Almost like arithmetics. Just need practice and it will be second nature. Practice. Okay, so example. Power of a quotient, right? I have the power of a quotient. I need to distribute my exponent to the every single thing. Everybody gets the same exponent.
So 4 squared.
Yep.
R.
So it's 4 squared, and then r to the power of 3 squared over 16 squared. Everybody gets the same power. By the way, right here I already used 2 rules, not just 1 but 2, right? Because first I distributed this second power to the numerator, and then using the other rule, the power of the product, I distributed it to both 4 and r to the power of 3, right?
Yeah.
So 2 rules already used. Okay, so 4 to the power of 2 is 16, right? And then r to the power of 3 to the power of 2 is what? Javan, what is r to the power of 3 to the power of 2? Yes, r to the 6. And then here I have 16 to the power of 2, and I'm not even going to calculate it because what? 16s will cancel out, right? So all I have is r to the power of 6 over 16. And that's my final answer. Let's just finish at least one more example, and then we didn't have time to practice. Which is, I guess, okay. No, one more example. One more example. Okay, so we have this power of 1 over 3. No, don't do that. We are still working. So the power is going to be distributed to both numerator and denominator, and then using that other rule, we know that every single factor in numerator, every single factor in denominator will get the same power, right? So 343 to the power of 1 over 3, and then x to the power of 5 to the power of 1 over 3, and then 27 to the power of 1 over 3, finally 5 to the 9 to the power of 1 over 3. Now, 343 to the power of 1 over 3, who tells me what that is? 7, right? So third root of 343 is 7, and then x to what power? 5 thirds over 27 to the power of 1 over 3 is what? We know that 3, and then y to the power of 9 to the power of 1 over 3 is what? Y cubed. Very good. So that is our final answer. Not too bad, right? So in the practice, you'll just put everything together.
Can you go back to the other example?
Yes. This one? Squared on the bottom here?
Yeah, I know.
Oh, see 16 here, 16 squared there. So 16 can be done.
So what is